of increments on subarrays to form a target array. So for this problem, we are giving a target array, but how can we get it from the initial array? So the initial array is going to be starting from zeros, so all the values going to be 0, and then we can do such kind of operations. So in one operation, you can choose any subarray from initial and increment its value by 1. So let's just check the first example. So in the first example, from the beginning it is a 0. Now we're going to choose such subarrays. It's going to be index 0 to 4. Now all the values are going to be 1. And then we're going to choose index 1 to 3. So this area is going to be 2. And then we're going to choose index 2. So this value is going to be 3. And this is going to be the target array. And the minimum operation is going to be 3. Yeah. So before solving the problem, let's just try to understand what kind of a pattern we're going to have. So if we have some patterns like 1, 2, 3, so this is 1, and this is a 2, and this is a 3. So I mean basically every number is in increasing order, so 1, 2, 3. Because for each of the operations, we can choose a subarray and we can increment by 1. So this means in this areas we can increment by 1, and in this areas we can increment by 1, and in this areas we can increment by 1. So it means it's going to be 3 operations. Yeah. So actually it is dependent on, if it is always in increasing order, so it is dependent on which value is going to be the maximum value. So this value 3 is going to be the maximum value. It is in increased order, so definitely we're going to choose this one 3. It is going to be okay. Yeah. So what if some patterns it is in decreasing order? So this is a 3, like here. Yeah. So currently we only analyze this, half of the problem. We didn't analyze the whole problem yet. So this is a 2, and this is 1. Yeah. So what are we gonna do? So the first one is a 3, and now definitely what do I mean is that we're gonna, for the first one, because currently for the first one, if we finish the first one, definitely we're gonna need 3 operations. But as the second one is lower than the first one, it is in decreasing order. So basically this means while we are doing for the first operation, we are also doing for this second operation. So this 2 will not include it. It's gonna just be 3. And what about this one? 1 is also less than 2. It is okay. So in total, it's gonna be 3 operations. While we are increasing this one, we're gonna increase these areas because it is a subarray. While we are increasing another one, it's going to increase this areas, and while we are increasing the last one, it's going to be the last one. So this means for the 2 neighbor values, if this one is bigger than this one, definitely we're going to choose the last one. Because if this is I and this is I minus 1, definitely we're going to choose the value of I minus 1. If I is less than I minus 1. If this I is less than I minus 1, definitely we're going to choose the previous value. So this means maybe we're going to use dynamic programming to solve the problem. Yeah, even for here, so for example, this person it is a 3, and this person inside of the dynamic programming, this value is going to be 3 as well. And if this one is less than this one, so the final value is going to be 3 as well. Finally, we just need to return the value of 3. Yeah, and similarly for here, if this is 1, this is I, it is okay, it is 1. Now the I gonna be shifted to the next one. This is I minus 1, and this is I. But this I, the value is 2. So what happens for this one? If this is bigger, it means we need an increment. So the value gonna be this value before, it is 1 plus 2 minus 1. So it's gonna be 2. So this means the value gonna be updated to 2. What about here? If we update it to here, the value is going to be 2 plus 3 minus 2. It's going to plus another one. It's going to be 3. Yeah. So this means if it is increasing, we're going to calculate it like that. If it is decreasing, we're going to calculate it, yeah, like fi is going to equal to fi minus 1. If it is decreasing. If it is increasing, fi going to equal to fi minus 1 plus the target I minus the target I minus 1. So this is going to be the formula. So what happens in these areas if it is just empty? So for example, it is a 0, 0, and 0. We have 3 zeros. So now we get a value of 3. This is okay. As this is decreasing. So what's going to happen? We just do nothing because this is just 0. Yeah. Now this is also 0. we just needed to do nothing, and this is 0, we just needed to do nothing. Now this 3 is more than 0. What's gonna happen for this one? Yeah, so if this value 3, so this is 0 and 0, 0. So if this value 3 is more than 0, yeah, normally this value gonna be less than. If this 3 is more than this 0, so basically our value gonna be updated. The previous value gonna be 3. So 3 gonna plus 0 plus 3 minus 0 plus another 3. It's gonna be 6. Yeah, so this is old calculation. So we're gonna use a dynamic programming. So the definition of the fi is what's gonna be the minimum number of operations until index 0 to index I. Yeah, so this is the definition. What is the minimum operations to form a target array from index 0 to index I. Yeah. So if the array is always decreasing, it will be like that, always decreasing like this line. So this means from here we've already calculated a result. Maybe this is a 5, and now we don't need to calculate it because it is always smaller. Yeah. So finally we just needed to return this value from the function f minus 1, going to be the final result. Now let's just use this idea, dynamic programming, to solve the problem. So we're going to prepare the length of the array, and now we're going to prepare a dynamic programming 1D array. It's going to be 0 times the target. So the first value, we're going to set it to be target 0. So this is going to be the first value. And then we're going to loop through from the second value. So from 1 to now we just need to check the target value. If the target I is more than or equal to target I minus 1, so this means yeah, we're gonna choose the current value. So fi yeah, let me just check the drawing. If I is more than I minus 1, so this means we're gonna use the formula. It's gonna be I minus 1 fi gonna equal to fi minus 1 plus the difference. So it's gonna be the target I minus target I minus 1. So else fi gonna equal to fi minus 1. So this means if it is smaller, if this value fi is smaller, target I is smaller than target I minus 1, so basically we're gonna choose I minus 1. Yeah. Now let me just return f minus 1 as our final result. Now let me just run it. It's gonna be yeah, as you can see it works. And let me just submit it. As you can see, it passed for all testing cases, and it's pretty fast. And the time and space complexity is ON because this is a directly 1D array linear dynamic programming. Yeah, I think that's all about it. Thanks for watching. See you next time.